I'm Judy Stamps. Today I'd like to talk about 3 protocols that have been used to study sensitive periods and why they matter. A sensitive period can be defined as a period in development during which a given stimulus or experience has a particularly strong effect on the phenotype as compared to other periods. Of course, sensitive periods have a long and distinguished history in animal behavior dating back to Lorenz's classical studies of filial imprinting. Since then, sensitive periods have been studied in many contexts, including song learning in birds, effects of cues from predators on development, and cochlear implants in humans. Now, 3 protocols have been used to study sensitive periods. We can call these type 1 the switch protocol, type 2 the plasticity protocol, and type 3 the window protocol. All of these protocols have been used to study sensitive periods in animals, but some of them are more popular than others in other contexts. For example, switch protocol is often used for studying sensitive periods in humans, and the plasticity protocol is often used to study neuroplasticity. Now, in each of these cases, subjects are exposed to an experience B starting at different ages, and the subjects are exposed to another experience A at other times. In the type 1 or switch protocol, we have different experimental groups, each of which are exposed to B starting at different ages, here, here, and here. The subjects are all exposed to A before B, and all of the subjects are measured at the same age, T. In the type 2 or plasticity protocol, we have, again, groups which are exposed to B starting at different ages, here, here, and here. And again, these individuals are all exposed to A before B. But in this case, the subjects are measured at the beginning and at the end of their exposure to B. So in this case, the individuals are measured at different times. Finally, we have the type 3 or window protocol. Again, we have different ages of onset to B. And again, we have exposure to A before B. But notice in this case that the individuals are also exposed to A after they're exposed to B. And also, all of the individuals are measured at the same age T. Well, this raises the important question of, does it matter what protocol you use to study sensitive periods? In order to answer this question, we use simple Bayesian models that focus on how an individual's information state changes as a function of the age of onset of a salient cue, in this case, B. Our assumptions are that there are 2 states to the environment, X and Y, that B is a moderately reliable cue that indicates that the state might be Y, and because these are Bayesian models, we also considered different priors. These are the subject's estimates of the probability of Y at the beginning of the experiment. Importantly, based on the way that empiricists have studied sensitive periods, we also considered 2 options for A. In the AI situation, we assume A is informative. That is, A is a cue, just like B is. But A indicates that the state may be X. On the other hand, the AU situation is one in which A is uninformative. In this case, we assume A provides no information about the state. For instance, in studies of sensitive periods in song learning, some investigators have used a design in which A is informative. In this case, A consists of one song, B consists of a different song. In contrast, other investigators studying sensitive periods in song learning have used a design in which A is not informative. In this case, A consists of silence, whereas B consists of a song. Right, let's look at the results. In all of the results slides, we're going to indicate priors across the top, and we're going to indicate the results from the A informative models, the top row, the A uninformative models on the bottom row. In all of the cases, we're going to have the same independent variable, age at onset of B. And as you remember, this is the common element in all of these different protocols used to study sensitive periods. What differs is the dependent variable. In the case of the type 1 models, the dependent variable is the estimate of probability of Y at age 20. Now, the results of the type 1 model show that in each case, the sensitivity declines as a function of age of onset of B. The relationship is always monotonically declining with age of onset of B, although the shape varies a bit depending on whether we assume that A is informative or A is not informative. For the type 2 models, the dependent variable here is probability of Y before B minus probability of Y after B. That is, how much did the probability estimate change as a function of the experience. In this case, in the AI models on the top, we again see declines, although not necessarily monotonic, in sensitivity as a function of age of onset of B. But in the AU models, we have a straight line in all cases. That is, no change in sensitivity as a function of age of onset of B. And in the type 3 models, if you cast your eyes across all of these, you see that we see a bunch of straight lines. That is, no indication here that there is any change in sensitivity as a function of age of onset of the stimulus. So, does protocol matter? Our results suggest that the answer may be yes. That is, based solely on first principles of information updating, we would expect to see sensitive periods if we used type 1 protocol, sometimes if we use type 2 protocol, and not at all if we used a type 3 protocol. Thus, we conclude that for some of the protocols used to study sensitive periods, we'd expect to see them just based on first principles of information updating. However, for some of the other protocols that have been used to study sensitive periods, you would have to add other assumptions to the models to explain why they occur. Thus, our take-home message is that when we're studying sensitive periods, protocol matters. Otherwise, we may be studying apples and oranges. Thanks for your attention, and I'd be happy to take any questions.